So let me summarize how to represent a strong entity, how to represent weak entity. So we have studied how to represent strong entity, how to represent weak entity, how to represent a relationship set, how to represent complex attributes in a relation, how to represent multi-valued attributes in a relation, right? So whenever you are going to represent a strong entity, it reduces to schema with the same set of attributes, right? So student is a strong entity, so we are going to reduce it to a relation student with the same set of attributes like id, name, and total credits. Whereas whenever you are going to represent a weak entity, right, then you need to combine, you need to find the strong entity on which the weak entity is dependent, and we need to include the primary key of the strong entity with the other attributes that are present in the weak entity, right? So here the primary key of the strong entity set is going to be course id, right? So the section is a weak entity set. It is dependent on the strong entity set course, right? So for course, the primary key attribute is going to be course id. So we are going to find the union of the primary key attribute of the strong entity set with all the other attributes present in the weak entity set to represent the weak entity, right? So the section entity set is a weak entity set. It is represented by the union of the primary attribute of the strong entity set on which it is dependent with all the attributes that are present in the weak entity set, right? So this is how we represent the weak entity set section. And whenever you need to represent the relationship sets, it should contain the primary key of the participating entities, right? So for example, we have advisor as a relationship set that exists between the instructor and the student, and you have two entity sets participating in the relationship set, advisor, student, and instructor. So the student primary key is going to be student.id, and instructor primary key is going to be instructor.id. So you contain the primary key of the participating entities in the relationship schema, right? So advisor is whenever you need to represent the relationship set by means of a relation, so you are going to have the same name as the relationship set. So the relation name is going to be advisor with the primary keys of both the participating entities. So then we discussed about how to represent complex attributes. So whenever you need to represent some complex attributes like name or street details, you need to flatten the attributes and then you need to represent it. You can prefix it with the complex attribute value, but you can also omit it if there is no ambiguity. So given some complex attributes, you are just flattening and you are going to represent it by id, first name, id comma first name comma middle name comma last name comma street number, street name, apartment number, city, state, zip, date of birth, and so on, right? So we also studied about how to represent a multi-valued attribute. So whenever you have a multi-valued attribute in a particular entity set E, it is represented, the schema is represented by EM, right? So the relation name is going to be EM instructor underscore phone, which contains the primary key followed by the multi-valued attribute, right? So ID is going to be the primary key and phone number is going to be the multi-valued attribute, right? So this is how we have represented multi-valued attribute by means of an relation, right? So we'll continue in the next class. We'll study how to avoid redundancy of schema design. We'll also study about enhanced entity model, right? So we'll study about enhanced entity model like generalization and specialization in the next class. And we'll try to cover this aggregation topic, classification, instantiation, and finally we'll try to conclude unit 1. Maybe we'll complete unit 1 maybe in one more class, right? So in this unit, again, whenever you need to have some whenever you need to have some questions, we have ER modeling, right? So you need to draw an ER diagram for an enterprise like a banking or a financial institution, for railway reservation, right? So you can draw some ER diagram for an enterprise, and you need to know how to convert an ER diagram into an relation schema, right? So that's more important. So you will be asked questions like construct an ER diagram for an banking and financial institution and reduce it into relation schema, right? So once you have constructed an ER diagram for an enterprise or for any system, database system that you plan to design, you are expected to reduce it into relation schema, right? So once you are asked to reduce it into relation schema, you need to know how to represent a strong entity, how to represent a weak entity, how to represent a relationship set, how to represent complex attributes, and how to represent multi-valued attributes, right? So we are left out with one topic like how to avoid redundancy in schema definition. So that will study in the next class. We'll also explore how to work with the enhanced entity relationship model in the next class, right? So any clarifications or any questions from the participants?
No, sir.
No, sir.
Right.
No, sir.
No, sir, it's clear.
Right. So thank you for your participation. We'll continue this in the next class also, and we'll complete the unit 1. Right. So thank you for your participation. We'll meet in the next